Hello everyone, and welcome to the Big Data Overview lecture. In this section of the course, we're going to start off with an explanation of Hadoop, MapReduce, Spark, and PySpark. We'll explain what a local system is versus a distributed system. Afterwards, we'll get an overview of the Hadoop ecosystem. Then, we'll switch gears with a detailed overview of Spark, and we'll show you how to set up Jupyter, Spark, and everything you need on Amazon Web Services. We'll also give you some resources on other Spark options in case you want to install Spark locally or on some other system. Afterwards, we'll dive right into the Jupyter Notebook with hands-on code, learning about PySpark and RDDs. And we'll learn about RDDs and what that stands for in the next lecture. Let's talk about big data in general. So far, we've worked with data that can fit onto a local computer, and that's usually in the scale of somewhere between 0 and 8 gigabytes. That's just data that can fit directly onto your RAM. But what can we do if we have a larger set of data? You could try using some sort of SQL database to move storage onto your hard drive instead of RAM. That will still work on a local computer, but if you need to expand beyond what your local machine can do, you can use what's known as a distributed system. That distributes the data to multiple machines or computers. Just to reiterate, a local machine is basically what we've been using. It's your own computer or a single machine where you're restricted to the RAM or hard drive of that one machine. On a distributed system, you can have one machine controlling a distribution of multiple machines. For instance, if you have one local machine, you may use all the cores on that machine. However, if you leverage the power of a distributed system, you can have one smaller master node controlling a distributed system of computers. That allows you to take advantage of this distributed system and actually retain more processing power and more memory than you would be able to on a single local machine. And that's what we're going to be discussing as we talk about Hadoop and MapReduce. As I previously mentioned, a local process will use the computation resources of just a single machine. A distributed process will have access to the computational resources across a number of machines connected through a network. After a certain point, it's much easier to scale out to many lower CPU machines than it is to try to scale up to a single machine with a high CPU. Distributed machines also have the advantage of easily scaling. You can just easily add more machines. Versus a single local machine, it's much harder to actually upgrade the CPU, and you're going to reach a certain limit. Distributed machines can also include something known as fault tolerance, which basically means if one machine fails, the whole network can still go on. Versus a local machine, if that goes down, your entire work goes down. Now let's go ahead and discuss the typical format of a distributed architecture that uses Hadoop. As a basic overview, Hadoop is essentially just a way to distribute very large files across multiple machines. It uses what is known as the Hadoop Distributed File System, or HDFS. HDFS allows a user to work with large data sets, and it also duplicates blocks of data for fault tolerance. It can then also use what's known as MapReduce, and MapReduce allows computations on that data. Let's go ahead and take a look at what a distributed storage or HDFS system would look like. You would have your main name node with some CPU and RAM attached to it, and then you would have several other distributed machines as data nodes. HDFS will use blocks of data, usually with a size of 128 megabytes by default, and each of these blocks is replicated 3 times. And then the blocks are distributed in a way to support fault tolerance, meaning if one of these lower data nodes gets knocked out for some reason, you have your data replicated on the other nodes, so you're not going to lose any information. Smaller blocks provide more parallelization during processing. Multiple copies of a block prevent loss of data due to a failure of a node. Now let's talk about MapReduce. MapReduce is a way of splitting a computation task to a distributed set of files, such as HDFS. It consists of a job tracker and multiple task trackers. The job tracker sends code to run on the task trackers. Those task trackers allocate CPU and memory for the tasks and monitor the tasks on the worker nodes. What we covered can be thought of in 2 distinct parts, using HDFS to distribute large data sets, and then using MapReduce to distribute a computational task to a distributed data set. Next, what we're going to be learning about is the latest technology in this space, which is known as Spark. Spark improves on the concepts of using distribution. Okay, up next, we're going to learn about Spark. Spark can use Hadoop distributed file system, but it has many advantages to just using MapReduce. Thanks everyone, and I'll see you at the next lecture where we learn more about Spark and how we're going to use it in this course.